Hello and welcome back. We'll continue looking at section 4.4 on counting. So one thing that will quite often happen is we'll want to look at different ways of arranging things, but there will be duplicates in there. And when there are duplicates, it doesn't really matter what order you put the same thing in. And I'll go through an example of this in a second, but the general formula is this. Let's say that we've got n items that we want to look at how many different arrangements are there. Well, in the past, it would just be n factorial. However, if there are duplicates, it doesn't really matter how some of these duplicates will be arranged, so we'll end up dividing by some numbers to make this a little bit smaller. What do we divide by? Well, if there are n1 items that are all the same, we'll end up dividing by n1 factorial. If there's another n2 items that are the same, we'll divide by n2 factorial. If there's another n3 items that are the same or more, we'll just keep dividing by n3 factorial and so on. So let's go through an example. How many different ways are there to arrange the letters of the word apple? Well, we see that there are 5 letters. And we look for any duplicates in here, and we see that there are 2 P's. So the number of ways to arrange the letters of apple. So the arrangements, or anagrams, I suppose, will be 5 factorial divided by 2 factorial. And then we can start. So this is small enough that that I can do this by hand, although in general factorials get to be quite big quite quickly, so we can cancel those out. 5 times 4 times 3 is 60. Let's look at another word. So how many anagrams are there of the word banana? Well, again, there are 6 letters in the word banana. There are 2 N's and there are 3 A's. So when we look at this, we'll take 6 factorial and we'll divide it by 2 factorial and another 3 factorial. The 2 factorial because the order of the N's doesn't matter, and the 3 factorial because the 3 A's, it doesn't matter if I arrange those 3 A's in any order, I can't distinguish them. So again, this is small enough I can do by hand. 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. And what I'm going to do is I'm going to look at, 3 times 2 times 1, that's the same thing as 6. So I'll cancel out the 6 and the 3 times 2 times 1. And then those two, so there are, in fact, the same number of ways to arrange the number of letters in apple as there are in banana, even though banana has more letters, but also more duplicates. So it all balances out. The last and probably most important thing in this section, and this is the one thing that I will encourage you to think about a lot, especially in the homework, is the difference between combinations and permutations. So we've been talking about ways to arrange things, and when I say the word arrangement, I tend to have a particular meaning, but we can distinguish between different sorts of arrangements. So permutations are arrangements in which different sequences of the same items are counted separately. So what I mean by different sequences, I mean things like this. Let me do this in a different color. So here are 6 different sequences of the letters A, B, and C. Each one of these is a different permutation. So the big point, the driving idea here is that in a permutation, order matters. Okay. The difference between permutation and combination is that combinations, the order doesn't matter. So the definition of a combination: combinations are arrangements in which different sequences of the same items are counted as the same. So order doesn't matter. That was a pretty big typo. So all of these, ABC, ACB, BAC, CAB, BCA, and CBA, are all the same combination of letters. So in a combination, order doesn't matter. Okay? So permutations, order matters. Combinations, order doesn't matter. Let's look at a few examples. Let's say that some people are going to run a race, and then we want to look at the ways in which people can finish the race. Well, when you're talking about finishing a race, well, there's someone who's going to end up in first place, someone who's going to end up in second place and third place. So the order matters. Which means permutation. Okay, so whenever order matters, we've got to think permutation. How about ways to select a president, vice president, and secretary? I'm thinking, say, like in a club, when you have a few members to vote on, and you have to vote on each one. Here, again, the order matters. Now, it's not order in the same way of thinking about something as in first, second, third, or fourth, or whatnot, but there is a president, there is a vice president, and there is a secretary. The person who's voted as president, it matters if they're voted as president or vice president or secretary. So in a sense, we could arrange these in order of president, vice president, secretary, and it matters which person is voted in which place. So here the order matters, as in the voting will change if someone was voted as vice president as opposed to secretary. So these are permutations. Okay, and how about this last one? Ways to select 5 members for a committee. So here, if we're just going to pick 5 members for a committee, it doesn't matter who's put on the committee first or who's put on the committee last. All that matters is the 5 people that are put on the committee. So order doesn't matter. So these are called combinations. And then, so one last one that I don't have written here. Normally, when you play the lottery, for instance, you're asked to select five numbers between two things, maybe between 1 and 40. So for lottery, ways to select. Let's say 5 numbers. Now here, you're not allowed to pick the same number twice. Not allowed to pick the same number twice, but the order that you pick them doesn't matter as long as you just pick five numbers. So since the order doesn't matter, this is just a combination. And one thing that I do want to emphasize with permutations and combinations is that these will refer to selections without replacement. So these are all permutations of letters A, B, and C, but for instance, A, selecting A 3 times in a row, that's not going to be a permutation or a combination. Permutations and combinations specifically refer to selection without replacement. So here's our formulas. If you want to pick R items out of N total items, there are two formulas that you'll need to remember. The number of permutations of r things out of a total of n is going to be n factorial divided by n minus r factorial. I apologize, my n's and r's look very similar. The number of combinations of r items out of 10 total things is going to be n factorial divided by, and this doesn't make sense, I need to fix this, divided by r factorial times n minus r factorial. These are formulas that you will need to memorize. They are very, very important. They look similar, except the combinations you're dividing by another number, this r factorial. So let's use these in some problems. For the first one, out of 10 competitors, how many ways are there for someone to get gold, silver, and bronze? So first of all, first thing we recognize is that order matters, because it will change if someone gets gold as opposed to silver or bronze. So we think permutations. So we come back up to our formula. The number of permutations. So n is the total number of things. R is how many we're selecting. So there are 10 competitors. And we are choosing someone to get gold, silver, and bronze. So we are selecting 3 of them, and we're putting them in order. So this is going to be 10 factorial divided by 10 minus 3 factorial. This will simplify. So this is 10 factorial over 7 factorial. And here, this is getting to the point where maybe it's a little bit easier to put it into a calculator. And this is, in fact, 720. So if a race is ran between 10 people, there are 720 ways for someone to get gold, silver, and bronze. Because order matters, we're dealing with permutations. So here, out of 15 members of a club, excuse me. So there are 15 members of the club, and 4 members need to form a committee. So how many different ways can the committee be formed? Well, it doesn't matter what order the members go onto the committee, so order doesn't matter. So these are combinations. Okay, so we come back up to our formula. So for combinations, it's very similar. It'll be n factorial divided by r factorial times n minus r factorial. So there are 15 members of the committee, and we need to choose 4 of them. So we will have 15 factorial divided by 4 factorial times 15 minus 4 factorial. This simplifies the 15 factorial divided by 4 factorial. 15 minus 4 is 11 factorial. And this is in fact 1,365. So there's a lot of different ways to form this committee.